All right, this is OXDF looking at advent of code day 9. Just giving this a skim through. So basically, I'm going to get a grid of depths, and I need to find the lowest, or I guess heights off the floor. So I need to find the low points, and low points are where any of the adjacent points are higher. So like this 1 is a low point because it's a 2, a 9, and a 9. This 0 has 1 and 1. This 5 has all 6s around it, etc. And I just need to find the low points and sum them up for part 1. So go ahead and give that a shot. Day 9. Oh, already got a little stub here set up to read the lines. A minute and get my data into a probably in a. I think I'm gonna do it in a dictionary. Hopefully. No, I guess I'm gonna do it. Get my data converted to array, a list of ints. So what that look like? For line and lines. I want to probably end up. Well, let's see. Line dot split. Split it into numbers. Oh, it's not going to split. So it's actually just for C in line at. So really what we want to do is int C in line. I think we can do line. Oh no, that's not what we want. C in line like that. For line in line that. So that's going to give us looking for. So we'll call this call it capital G for grid. I think I'm going to end up be typing a lot, so I'm picking a really short name on purpose. In fact, let's look at what that gives us. Python data. Wait, example. That's not going to work well. Didn't like 2 4. Rid of 1. Literal. Okay. Move the white space from the outside. With dash I, so we can get to the end. What does G look like? 2199. Okay, so that's exactly what I'm looking for. So if I wanted, I will give G a y coordinate and x like that. So if I want, I assume that this 2 is at 0 0. So if I wanted to go to like 3 1 2 and get this 6, it's going to be b of 2, 3. I get the 6. Sweet. That looks good. I'm reading the data in. So I need to look for low point. I'm gonna define something I think is gonna come in handy right now, and that is get a of y, and that is just going to return, let's say like deltas equal 1 comma 0, 1 comma 0 comma 1, and -1 0 comma 1. Now what I can do is I can say turn x for x deltas. Ooh, I'm not going to call it x. D for D in deltas. What I really want to return is couples. So I'm going to do x plus d sub 0, comma, y plus. So this will be 4. This will create an array that's 4 long at the moment. I'll change it in a second. And it's going to get me each of the 4. So it's going to be x. one more x without changing y, one less x without changing y, one less y, and one y. The other thing I want to do, if um, x less than, well, let's see, the x is the second one, so then of g sub 0 that, and y is less. I think that'll work. What I'm trying to do here is avoid, if I pass in this 0, right here, if I pass in 0, 0, I only get back two things. So if we can test that, I just do get a comma 0, get an empty string. That's not good. Oh, hold on, let's fix this. Less than, again. Okay, I can see the problem. If 0, try one more time. Why it's good to do these little tests here. Still not working. How would that pass? Because x and y are not what I'm testing here. What I need to do is test x plus 0, insert mode, x plus d0, y plus, being kind of sloppy here. Let's see if we can get over. There we go. So now I got the two neighbors back on 0, 0. So 0, 1 is a bit confusing because actually this right here, oh no, 0, 1. So x, okay, so that would be the, yeah, I'm wondering if I'm messing up my, it's confusing because in G it goes y, x. I'm wondering if I should be that everywhere, or if it matters. I feel like it's going to confuse me. It's yeah, you know what? I think is the easiest way to handle this actually. Back here and change our G. Talked about doing this at the beginning. Make it a dictionary. Um, so um, to comma y b for ugly. This is ugly to figure out too. Maybe I'll leave it. Okay, let's leave it for now and see if we can do it. Might regret this. We regret it. Regret it already. Okay. Um, so if we do 4 for y comma lines, right? Lines. So I can get the y value. Line is going to be for x comma b 9 7 y b terrible. 0 0 is 2. 0 1 0. So that would expect to be this. Now standard xy. 2 0 is 9. That looks good. Okay, I got to do a little bit of work here to do script. Get rid of the white space. Get rid of that new line there. What else do we need? We need to make b into pretty nice. Copy that. Grab it in here. There we go. So now my get neighbors function is also working in this. So everything is x, y. Okay. So what do I want to do here? I need to just loop over all the spaces and check and see if the neighbors are all higher than. So for call this lows, this for point G, if which is our we'll do get a on point. I think that should work. And that'll return 4 values. We want to see, well, somewhere between 2 and 4 values. We want to see if they're all. Actually, we're gonna do a loop here. Another, I love those comprehensions. Okay, so we're gonna do P for P and get neighbor, and we're gonna do P. We're gonna do G sub P greater than G sub point. All. Basically, what I'm saying I'm going to do here is I'm going to get all the neighbors, be somewhere between 2 and 4. Then I loop over those neighbors, P, call those N, but and say if all of them are greater than that, then I know this is true. So I'm going to lows dot end point. Let's see if this works. Argument. I need to get this way where I pass in a P sub 0 comes 1, 0, 1. Getting kind of ugly, but it'll probably work. Error. Go ahead and smaller because I don't space. Okay, it's in that return. Let's check on it. Go ahead and import the debugger. Okay. We will build it up from base. So what happens if we just debugger does not work well in Oh, yeah. Oh, I bet it's G. Then that's okay. Because I'm no longer because the way I'm storing G now, I don't have got 50, but it's really n by 5. So it's giving me shoot. All right, so what can I do to get the max? Please. rid of this, but the x maximum x is going to be 10. What I want it to be is b dot key x x y. Is the x values? Nope. Wait. Yep. To x. But now I've copied my g max, my gx max. I'm gonna go to gy. Same thing. I think it should work here. That. Yep. Y. There. Now we can come down here, find our issue. Now we need to no longer be full x full y. Work. Rid of our what we know what was breaking. Okay, lows. 4 of them. 1 0. Huh? 9 0. Yeah. 2 2. Okay, that doesn't look. Oh wait. 0 1 2 5. That looks right. And 6 4. 6. That one right there. Let's see. That looks pretty good. If you're right. So let's see what's the sum of the risk levels. Well, the risk level is 1 plus the height at the lows. Okay, so I need to get of lows plus 1 sum that 1 equals and print one. See if that works. 15, that's what I'm supposed to get in the example. See what my puzzle input. 4 5 6. Got a gold star. On to part 2. Okay. I'm going to pause real quick and read this. Okay, so the idea here is that I need to look where, for each of the low points, I have to look for expanding out around it until it reaches a point. So, like this 2, I'm looking for where like water would flow down into, right? So, like this 4 flows into this basin, and it's only going to flow into that basin. So I'm looking to like these form these basins, but 9s are considered infinitely high and they don't count. Basically the sum of it. So I need to find all the basins. There's going to be one basin per low point. Even if that low point, if you assume 2 low points aren't next to each other, then there's going to be one basin per low point. If there's even one gap apart, they can just be a basin of 1. I need to find the 3 largest basins and multiply their sizes together. This is tricky. Thought about this a little bit, and what we're going to do. So we know there's one basin per low point. So we can start by saying basin set of the. Now we've got a list of sets of the basins we're going to have. Make sure that works. Sets all that often. Ooh, what did I do? That's not what I got. Okay. I'm glad we checked. I'm not exactly sure what I just did there. P for close. Close? Close all. Oh, because I'm not looking at the example anymore. Okay, that looks better. Huh. I'm gonna have to convert these to strings or something so that they go into sets more. Um, is close this? What is? Okay, we'll try that and see if that works. Ooh, I don't know if I like that. That it looks like what I can't do is I do a set 4 times. Oh, that looks better. If I do that, that. Okay, there we go. Okay, now I've got a list of 4 sets that contain 1 point. That's what I'm looking for. Get rid of. Do that. That will give us. So I bet you there's a more efficient way to do this, but I can't think of what it is. My plan is going to be, well, hopefully this will work out, is that I'm going to start at the lowest value, the 0. We know the values go 0 to 9. And I'm going to check all of the points that have a height 0 and make sure and see if they're already in a set. Let's see, what am I going to do? I'm going to check the neighbors for that point. And the neighbors for the point, there's no neighbors in a set. That means it's a low point. I should already set that shouldn't happen. I guess first I'll check and see if the point is already in a set. If it is, I'm done with that point. I'll move on. That should only be the low points to start. Then I'm going to check and see, look at the neighbors for that point and see how many sets they fall in. And if they fall in one set, that just means it attaches to that set because it's means the other points around it are not in a set yet, and means they must be higher. If it's in 2 sets, that means it's a straddle point. That means it'll be something like, if I have like 0, 1, 0. And so I would have 2 sets, this one, 2 basins, this one, and this one. And when I check this point, it falls in both basins. And that to me is no longer, um, a part of either basin. So it's like a dividing point. So then I would just not put it in any set. So if it's in 2 or more, then I would move on. So I'm going to end up looping through my entire data set 10 times. Each time check getting points that are the same height, but I think that's okay. Because this is not huge. It might come back to bite me. We'll see. So I'm going to do for h in range 0, comma 10. I guess I'm just do 10. Then I'll do for x in x range x, for y in range y, actually do plus 1. One. So now I will loop through. If g of x comma y equals h, if it's that height, I will say if let's see, any x comma y in S or S basin. That means it's already in a basin. Cool. I'm done. I don't need to do anything. Then I can do get nay with the point. I'm gonna loop through those. And R comma C for row. I guess it's be C comma R. C comma R in. Okay, so I'm going to do a loop over all of the neighbors, and I will see if comma R in see, I'm trying to check and see if it's in any of the basins. So we're going to do this not in list comprehension. How about that? For nx, ny, neighbor x, neighbor y in get name. That'll work. And get name of x, y. I need to know the sum of the any neighbor. This is like the logic here is getting me first. So then I'm looking at the neighbor. I'm not looking at the neighbor, just looking at the point. Oh, and seeing if the neighbor sets contain a neighbor. I'm really looking for the number of sets that contain any of the neighbors. So let's come back here. We're gonna do our thing is gonna be S for S in basins. We're trying to make a list of basins, right? We only want to have that be if that this is where we're gonna do next y get a y. What I'm going to do here is make that a tuple in S. Any of those come back true, and then I want to keep the S. Say basin. We can just do yes. We'll do basin. We won't do that if when what's something simple we can call it touch when touch one um, touch sub zero dot add y like that. That work? A sub zero. That's what we're doing here. We're going to get one of them. B dot add and just list even good. Set actually state basin. Let's keep it. F sub zero add. Maybe that's it. 'Cause if it's more, it should never be zero, and if it's more than that, I just want to do nothing and move on. That good. See what happens if we run. Okay, the basins have some size to them. Um, look at what the basins were in here. So the first basin was basically those 3 points on the edge. That's those 3 points there. That looks good. The next, oh, I made a mistake. Okay, I'm noticing something here. I'm not supposed to include 9. Um, so if the value of the point is 9, don't include. What do I add? Any of them are in the basin for G sub Y 9. Okay. Oh, I don't know if that was necessary or not, but I don't think it's gonna break anything, so we'll leave it for now. Let's maybe do len s for ooh. Okay, that's not that though. That is the sizes that I'm supposed to see. That's awesome. Um, so I'm feeling pretty comfortable. So we'll do p2 equals sorted n s in basin. We want the biggest three there. Then we want to multiply for math equals 2, 3 like that. Not good. Put the colon in the wrong place like that. Cube minus 3. But it's sorted that. That'll be the 3 big ones. Do math.prod. Hope that works. 1134 the answer. Four. So I'm going math.prod. I'm going to fix my colon over here. I'm going to print string part 2. Close it. For math. Gosh, I really matters at this point. Ooh, is it gonna run too long? Oh no. This is the part this is what I was scared of. No, it's not. No, that's again, I don't know this is the most efficient solution, but it was hopefully a right solution. It didn't take too long. So I think that's it for the day. I'm gonna go ahead and I guess I'll do my, try to wrap up and make sure I explain what I did here. Because I don't know how much I ramble when I'm going here. First thing I really did was loop over my lines here, reading into a dictionary where the key was a tuple of x and y, and the value was the integer value. I made sure to get the maximum x and maximum y, so I'd have those for multiple places. I have this get neighbors function, which takes a point, which is a xy tuple, and then just returns the 4 points around it. Well, 2 to 4 points, depending on making sure to check within bounds. Get the lows, I loop over each of the points in G, and if every point, so I say I get the neighbors, and if for all the neighbors they're greater than the point itself, then it's a low, and I append it, and then I can print out, calculate the value they want, 1 plus the sum of those values. For part 2, I made the assumption, well, no, I made the statement that all basins are going to start at a low point. And so I can put those into a list of sets. So I have a list of basins. I then loop over the heights, 0 to 10, about 0 to 9. And for each of those, I run through the entire array. If I find one that has a value of that height, um, I can start first if that's already in a set, or if it's got a value of 9, because those are kind of magical. I'll just continue going. Um, I guess actually I could just stop my. I don't need to. That's dumb. What that makes it faster, or like 10% faster. I can just do 9 here and just not worry about the ninth row because I don't want that way I won't have it. Okay. Um, if it's already in a basin, just continue. Then I'm going to see what are the basins that touch um, this point. So I'm going to get the neighbors, and I'm going to loop over those. And if the neighbor is in S, I'm going to basically I'm going to loop over the basins, have just basin here. My basin being a set of points. But I'm only going to keep basins where the neighbor has one of them. That's going to be touch. And if length touches 1, that means it touches touches only one basin. That means it's a part of the basin. All the water flows into that basin. So if only it's by definition higher than the points in the basin because I haven't done. If I'm a height of 5 right now, all the points in the basin must be 4 or less. I guess it could be 5 or less. So water's going to flow in there. If the length is 0, that means I should have found a low, and it means that I shouldn't get to 0. If the length is more than 1, it means it's a straddle point. So I'm going to ignore it and not put it in any basin. And then I just sort the basin, get the lengths of the basins. I sort it, and I get the last 3 to get the biggest 3. And then I call the product, and I print. It worked. So I will wrap it up here. All right, this is OXDF. I'm back. I did a little bit of reading on how people looked at this. Just I always like to look at other people's solutions. A lot of people, the common solution was to assume that all basin edges were 9. Basically, not have in your anything that looked like 1, 2, 2, like this. Because in this case, if this is a low, both the zeros are lows. This 2 can't be in either basin. And apparently in the puzzle output, that will always be a 9. There won't ever be a 2 that sits with basins like that. So if I could just look for 9s that way, that makes it probably a lot simpler to do. I don't think that fits. To me, that didn't fit the problem. Maybe I misread it. I could go back and look again, but that to me feels like you're kind of guessing that that's going to be the case, and it's not guaranteed to be the case. So I don't like that. I like my solution better, even though it's probably much slower. So anyway, thought that might be interesting to you, and yeah, I'm gonna call it here. Thank you so much for sticking around till the end.